Hi, I'm Saradeep. I'm a sophomore studying computer science at ASU. Technically, I'm a junior, but yeah, I'm on second year. And I wanted to share a quick demo of my recent project that I've been working on. It's called CyclopsMIPS. So it's a cycle accurate MIPS CPU pipeline simulator that I built entirely from scratch in C++ and OpenGL using Dear ImGui for the front end. My goal was to create a tool to visualize bare metal execution. As you can see, the UI is broken into several chunks or panels. The main panels are these four: the architecture schematic that you can see, which is actually referenced from the Peterson and Hennessy book of MIPS computer organization. You can see the pipeline data path that basically can track stages cycle by cycle for instruction fetch, decode, execution, etc. etc. You can see the real-time control signals for each cycle, and you can also see the real-time memory and register data for each cycle. Let's move to describing a more visual code, shall we? Let me copy the instructions that I had stored. So basically what we're doing is we are loading a very simple 4 instruction sequence. So this is the code editor where you can input MIPS assembly code here. And what we are seeing here is we have 2 registers, two immediate additions into registers, basically on T0 and T1, and then we are basically doing an R-type addition, summing those into T2, and then we are finally using a store word instruction to write that result back into the memory address 0. So here the ground truth that we are looking for is register T0 holding T5, register T1 holding 10 or hex A, and register T2 holding 15 or hex F, and memory address 0 being overwritten with hex F. So for a heads up, R8 is T0, R9 is T1, and R10 is T2. So basically, let's run this app right now. So first of all, we will compile the MIPS code to assembly, or technically machine code first. So MIPS assembly gets compiled to machine code, and then we will basically run this cycle by cycle. So if you see properly, I will run 5 cycles. If you see now, store word has been loaded at cycle 4 in instruction fetch, and it's currently sitting at instruction decode in cycle 5. If we move to pipeline signals, you will be able to see that there are many control signals here for basic control, hazard and reset, and also for forwarding. So these controls are basically real time, so they will update real time for each cycle. So what we will do is we will now step from cycle 5 to cycle 6. Alright, so if you see very clearly on cycle 6, or technically I think we are in cycle 6 now. So in cycle 6 you can see that memwrite is 1. If I move back to pipeline data path, you will see that we are currently in the execution stage. So technically what happens here is during the execution stage of store word, the memory write signal gets converted from 0 to 1. That's the ground truth, and we are basically saying that the generated section from CyclopsMIPS is correct with respect to the ground truth. Then we will step from cycle 6 to cycle 7. You will see that we are updating R10 with F, but that's not that important. When we are on cycle 7, we will see that basically we are now on the memory phase, right? So we are on the mem phase here. So what happens here is store word will now write its information back to the 0 address, right? So it will write its answer to address 0. So it will write F, which is at address 0. So that's correct. Now let's move on to registers, and if we step one cycle again, so now from cycle 7 to cycle 8, you can see that store word is at write back stage now. This is the last stage, and here if you see clearly, R8 is 5, so T0 is 5, R9 is A, that's T1, and R10 is F, that's T2. So as we can see, basically the entire execution cycle can be verified pretty easily and intuitively to develop that skill required to kind of understand how a MIPS pipeline architecture works. And this is a much better visualization than any other. I would say like this is like one of the ways that I think students might be able to understand. So let's move back to the conclusion. So as you can see, the final hardware state perfectly matches our expected ground truth. Moving forward, I plan to transition this engine into a fully fledged educational MIPS simulating IDE. I struggled heavily with computer organization when I took this class here at ASU, and I wanted to provide a more visual, interactive tool to help future students grasp these concepts. Building this tool has also solidified my understanding of low-level systems and memory management, and I'm also very thrilled to kind of learn these and build that systems engineering mindset, and also apply them in real-world cases like research or maybe on industry. If you have watched till the end, thank you for watching. I hope you have a great night or a great day. Bye-bye.